Okay, let's do another example. Function obviously is different. 2x squared plus y to the third minus x minus 12y plus 7. Steps, I left all the rules here to the right, and these partials kind of same step as the last video. So looking at f, partial x, we get 4x, 0 minus 1, and then 0, 0, right? Partial y, we get 0, we get 3y squared, and then 0 minus 12, and then 0. Okay. Again, let's do second partials while we have it. So the second partial with respect to y, we get 6y, and then that's 0. Second partial x here, we just get 4. And then again, we need the second partial y then x, or x and y. We should get the same thing. So looking at this one, if I did partial with respect to x now, because we did y, right? So with respect to x, I get 0. If I look at this one and I do partial with respect to y, since I already did x, again I get 0. So our second partial with respect to x then y, or y then x, either way, they're going to come out the same. We get 0. Alrighty. So there's all our partials. We're ready to go on this entire problem. First step again, we need to find the possible maxes and mins. And to do that, we set our partial x and our partial y equal to 0. So partial x equal to 0. That's 4x minus 1 is 0, which would mean x is 1/4. Okay, partial y equal to 0. That means 3y squared minus 12 is 0. Add 12 and divide 3, we'd get 12. 3y squared, we get 4 equals y squared. Remember, when you square root, we do need plus or minus here. So for y, we actually get two different values, a positive or a -2. So what does that mean? That means possible relative maxes or mins, max or min, occur at, well, x is 1/4 and y we could get +2, or x is 1/4, y we get -2. Okay, we have to check both of those. So moving on, next we need d. Now for d, if we have a variable, we have to check both of these, right? This will be like one point we're checking, this is another point we're checking. So d of, we'll do the first one, 1/4 2. It tells us take the second partial x. Well, that we got 4, multiplied by second partial y, which is 6y, right? But y is 2, right? Y is 2. So 6 times 2 is 12. Minus the second partial xy squared. Well, that we got 0, right? I'll write it, but it's 0 squared for that last part. So d then is 48, which is positive. All right. So for this first one, we got d is positive. Now we need to check second partial x. Well, that was also positive, right? We got 4. So since d is positive and our second partial with respect to x is positive, that means that 1/4 2 is a relative min. Okay, that first point is a relative min. I'm going to switch colors here. Now we need to check the second point, 1/4 -2. So d 1/4 -2. Okay, second partial x, again, that was 4. And then second partial y, again, it's 6y, but now I'm substituting -2 in for y, so it'd be -12. And then again, I'll write -0 squared just for good measure, but, you know, obviously 0 squared is 0. So negative 48, which is less than 0. If d is less than 0, rule 3 tells me it's neither a max nor a min. Okay. If d equals 0, it's inconclusive, which means I don't know. Okay, it might be a max, it might be a min. The test didn't give us enough information to truly know if either of those are true. All right, so this point for sure is not a max nor a min. So 1/4 negative 2 is neither a max nor a min. Now, I can't draw in 3 dimensions, but you know, kind of picture like second derivative test and a single variable. Maybe we got a derivative of 0 or inflection point, right? And it wasn't a max or min because, like, say we did that. So the derivative actually came out to be 0, but it kept increasing. So picture that in 3 dimensions, maybe, you know, like, might be what we call a saddle point. Again, horrible artist here, but we have some sort of curvy figure in which it stops for a second and then keeps going up.